Hello one and all, I am Farhan Haider and welcome to a short talk on impacts of UC formulation tightening on computation of convex cell prices. This work was jointly done by researchers at Rochester Institute of Technology and University of Connecticut. To understand our work better, let's go over the background information. In US electricity markets, the state of practice is to set prices by solving the economic dispatch problem, with commitment decisions fixed at optimal values from the UC problem. Although this method is easy, it does not take into account fixed costs such as startup and no-load costs, which can be seen on the figure on the right, which shows you the cost function. Price is calculated as the slope of the cost function, and as fixed costs are not captured, the slope of the cost function is not monotonically rising. Due to these issues, large uplift payments have to be paid to units as compensation for lost opportunities. One novel approach to reduce uplift payments and get more accurate prices is convex cell pricing. There are two methods of getting convex cell price. First is by slope of the convex hull of the total cost function. The red curve on the right figure on the right shows the convex hull, and its slope gives us the convex hull price. As you can see, the slope of the convex hull is monotonically rising. The other method is by using dual variables associated with the system demand constraints of the UC problem. In this talk, we considered the second approach and combine it with decomposition and coordination methods along with formulation tightening. We use a decomposition and coordination method called surrogate Lagrangian relaxation for fast convergence. Tightening of subproblem formulation is done for reduction of computational efforts. The main idea behind formulation tightening is that tight constraints directly delineate the convex hull of the feasible set. This can be seen on the figure on the right. The red lines represents the tight formulation and blue lines represents the not tight formulation. For a tight formulation, the optimal solution to the LP problem is also optimal to the MILP problem. However, if the formulation is not tight, these optimal solutions are different. Hence, we try to understand the impacts of formulation tightening on computation of convex cell prices by using the SLR method. We now discuss the implementation of our idea. We compare the performance of our tightened UC formulation with the conventional 2-bin formulation, and both methods are solved by surrogate Lagrangian relaxation. We also consider the IEEE 118 bus data and perform two experiments. One is a 3-hour example and the other is a 24-hour example. We use a tight formulation for the 3-hour example and the results are shown in the table. Convex cell prices are obtained under conventional and tight MILP formulations. However, upon integer relaxation, the conventional formulation cannot give us convex cell prices as prices are not same. But if the formulation is tight, upon integer relaxation, it gives us convex cell prices as both prices are still same. Moving to our 24-hour example, we use the same 118 bus IEEE dataset but for 24 hours. And here we use a tightened formulation, which is a near tight formulation. In the figure on the slide, the blue markers represent the prices from the conventional MILP formulation. Orange represents the LP conventional, and yellow represents the tightened LP formulation. As you can see, the yellow markers closely follow the blue markers. However, the orange markers do not follow the blue markers that closely. This shows that a tightened formulation can give approximate convex cell prices upon integer relaxation. In conclusion, the impact of formulation tightening on computation of convex cell prices was analyzed in this study by comparing the performance of a tightened formulation with a conventional 2-bin formulation, and both problems were solved using surrogate Lagrangian relaxation. The IEEE 118 bus dataset was used for testing, and results show that for the 3-hour example, tight unit level formulation provides accurate convex cell prices upon integer relaxation. While for 24-hour example, the tightened unit formulation provides approximate convex hull prices upon integer relaxation. This demonstrates the potential of formulation tightening on convex hull prices. Thank you very much.